Assalamualaikum everyone. Today we will talk about the relationship between pH value and temperature. This is our member, which is we have 3 members. So what the background of this study? This study examines how pH value relate to temperature as per our key environmental indicator affecting reaction rates, microbial activity and water quality. Temperature change can influence hydrogen ion dissociation, leading to pH fluctuation in natural water. This shift may impact aquatic life, water treatment, and biochemical processes. Understanding this relationship improves monitoring accuracy and support environmental data analysis. So this is objective we want to achieve. First, we have to identify the relationship between the pH value and temperature. Second, to develop a linear regression model. Last, to predict the temperature using the linear regression model. The significance of this study is the finding may help provide insight into environmental monitoring, support academic knowledge, and contribute to understanding how pH relates to temperature change. So, limitation. This study is limited by the small sample size of 6 data points and the narrow range of environmental conditions. Time, data availability, and scope of variable also limit the study. Data description. The data show a result from an experiment where the activity of enzyme amylase was tested by mixing it with starch solution to see how effectively it could break down starch into sugar. The pH of the solution was also measured and stayed very close to the natural. The range from 6.72 to 7.12, which is the optimal pH for amylase. The temperature of the solution was recorded at different time and ranged between 27.8 Celsius and 29.6 Celsius, which is warm and stable range ideal for enzyme activities. The population of this study represents all enzyme reaction involving amylase breaking down starch into sugar under different environmental conditions. The sample of this study consists of specific amylase starch reaction mixture stats at selected pH value and temperature in this experiment. In this study, both pH value and temperature show continuous quantitative data because both are using numerical measuring processes. In this study, the pH value and temperature are classified as interval scale measurement because they are numerical variable with equal units between value, while the enzyme activity measured by the amount of sugar produced is considered a ratio scale variable since it has true 0 point.
For graphical technique, the most suitable graph for this study is a scatter plot graph because it is used to show the relationship between two continuous variables. Plotting temperature on the x-axis and the pH on the y-axis, the scatter plot allows the pattern or trend between these two variables to be clearly observed. This scatter diagram forms a certain pattern, such as increasing or decreasing, indicating that there is a relationship between the two variables.
Mean is known as a measure of central tendency that represents the typical of value in a dataset. The formula for mean is known as a mean equal to total of x, fx, divided with total of f. Total of f is known as the total frequency, while total of fx is known as the sum of the product of a frequency of each group and their corresponding midpoint. While the median is the measure of central tendency that represents the middle value in an other dataset. The formula for median is the median equal to Lm plus with the multiply of the n divided with 2 minus with the total of fm minus 1 divided with fm, and all of that will be multiplied with the c. Lm is known as the lower limit of median class, while n is known as the position. The total of fm minus with 1 is known as the cumulative frequency before the median class, while the fm is known as the frequency of the median class, and the c is known as the class size. Mode is known as the measure of central tendency that identifies the most frequent occurring value in a dataset. The formula is mode equal to L plus with the f0 minus with f1 divided with f0 minus with f1 plus with f0 minus with f2, multiply with the c. L is known as the lower boundary class, while f0 is known as the frequency of the mode. F1 is known as the frequency of the mode before, f2 is known as the frequency of the mode after, c known as the class size. The relationship between mean, median, and mode. For symmetrical distribution, mean equal to mode, the data will be evenly spread like a bell curve. For positively skewed or right skew, mean will be greater than the median, and median will be greater than the mode. Hence, the tail extends to the right and pulling the mean up. In addition, for negatively skewed or left skewed, mean is less greater than median, and median will be less greater than mode. Therefore, the tail extends to the left and pulling the mean down. For measure of dispersion, it gives an additional information to judge the reliability of the measure of central tendency and helps in comparing dispersion that presented in the various sample. Some examples of measure of dispersion are range, variance, and standard deviation. Correlation analysis is a statistical method utilizing the Pearson coefficient to measure the direction which indicated by the sign and the linear string which is indicated by the magnitude between -1 and 1 of the relationship between two quantitative variables. Value of correlation coefficient always lies between the value of negative 1.0 or 1.0 indicate a stronger relationship, meanwhile the value closer to 0 indicates a weaker or non-linear relationship. The formula for correlation coefficient is R equal to total of xy minus with total of x multiplied with total of y divided with n, and all of that will be divided with the square root of the total of x square minus with total of x multiplied with square divided with n, and all of that will be multiplied with the total of y square minus with total of y multiplied with square divided with n. R is known as a correlation coefficient, N is known as a number of observation, total of xy is the sum of the product of x and y, total of x squared is the sum of square of value of a variable x, total of x multiplied with the square is the square of the sum of all the value of the variable x, total of y squared known as the sum of the square of value of variable y, total of y multiplied with square is the square of the sum of the value of the variable of y. For a regression analysis, the data was collected and then plotted on a graph. A computer or a calculator is used to draw a best fit line or curve that represents the overall pattern of the data. The line shows the direction and the strength of the relationship. If the line slope upward, it means as the independent variable increase, the dependent variable also will be increased. If the line slope downward, the dependent variable will be decreased as the independent variable will be increased. There is two formula for the regression analysis. Number one is B equal to total of xy minus with the total of x multiplied with the total of y divided with n, and all of that will be divided with the total of x squared minus with x total of x multiplied with square divided with n. The total of xy is the sum of xy, and the total of x is the sum of x. Total of y is the sum of y, and also total of x squared is the sum of the square of each x value, and also n is known as the sample size. The next formula is A equal to the total of y divided with n will be minus with b and will be multiplied with the total of x divided with n. The total of x is known as the sum of y, n is known as the sample size, total of y is known as sum of y, b will be known as the slope.
Data presentation. So this is the data presentation and the scatter diagram. For the interpretation, there is a positive correlation between the temperature and pH. Descriptive statistics analysis. For mean, the average of temperature is 28.583 degrees Celsius and pH is 6.9183. For median, 50% of temperature is less than 28.55 degrees Celsius and another 50% is more than 28.55 degrees Celsius. And 50% of pH is less than 6.915 and another 50% is more than 6.915. For mode, the most of temperature is 27.8 degrees Celsius and the most of pH values is 6.72. Correlation and regression analysis. First, we need to find the correlation coefficient R and substitute into the formula. We got R equals to 0.97. Next, we need to find the R square coefficient of determination, and we got the answer is 94.09%. As we can see from the output from SPSS, from the calculation based on formula and the output from SPSS, the correlation coefficient R is 0.988. There is strong positive relationship between pH and temperature. For coefficient of determination, R square equals to 0.976, means that 97.6% of the total variation can be explained by the regression line using the independent variable. Temperature, another 2.4% can be explained by other factors. So next, we want to find a slope, which is B, and we substitute into formula and we got B equals to 0.207. And for the intercept, which is A, we substitute into the formula and we got A equals to 1.0016. The regression equation is y equals to 1.0 plus 0.207 x. For every degree of Celsius of temperature increases, the pH rate increases by 0.207. From the coefficient table, dependent variables is pH rate. pH rate equals to 1.00 plus 0.207 temperature, indicating that each 1 degree Celsius increase in temperature increase pH by 0.207 units. The standardized coefficient beta equals to 0.988 demonstrates that temperature has a very strong influence on pH. The intercept was not statistically significant. B equals to 1.00, P equals to 0.098. Overall, the findings showed that pH increases consistently with higher temperature. From the ANOVA tables, results showed that the overall regression model predicting pH from temperature was statistically significant. F equals to 162.56, P less than 0.001. That indicates that the model explains a significant portion of the variance in pH values. In conclusion, this study investigated the relationship between temperature and pH in amylase catalyst starch hydrolysis. The results show a strong positive correlation between temperature and pH. R equals to 0.988, P less than 0.001, indicating that as temperature increases, the pH also increases. The linear regression model, pH equals to 1.00 plus 0.207 temperature, further confirms that each 1 degree Celsius increase in the temperature leads to a 0.207 unit increase in pH. The model was statistically significant F equals to 162.56, P less than 0.001, with a high coefficient of determination, R square equals to 0.976, suggesting that 97.6% of the variation in pH can be explained by temperature. The findings demonstrate that temperature is a strong and reliable predictor of pH in amylase activity, highlighting the sensitivity of enzyme function to environmental conditions. For recommendations, future studies should increase the sample size, examine additional factors affecting enzyme activity, and explore a wider range of temperatures and pH values to improve the accuracy and applicability of the findings.